Alright, hello everybody. So, last time we had a quiz, and so I haven't gotten everybody's quiz yet for this class. I'm going to wait until I get those all done to pass the grades back and then go over that quiz with my Zoom class. So for today, it's going to be a pretty short lecture. We're going to be going over the properties of exponents. So, we have gone over expressions and equations, but we haven't gone into a whole lot of detail with them. And so that's what we're going to be doing now, is we're going to say, all right, we understand how the basics work. We're going to start adding a little bit of detail now. So, exponents are things that can add a whole lot of interesting complications, let's say, to our expressions and equations. So first of all, I've already gone over this before, and this was in the quiz. And that is, what does this come out to be? -2 quantity squared. And when I say quantity squared, I mean the entire thing in the parentheses is squared. Okay, so remember that parentheses make everything in here basically like one solid number. Everything in here is treated as one thing. So when we square it, it's all going to get squared. The entire thing, not just the 2, but also the negative. So when we start thinking about this, it's like saying we have -2 in parentheses times another -2. Oops, forgot the arrow on that. So -2 times -2 is -4. I'm sorry, -4, +4. Because negative times a negative is a positive. So we already know that one. However, there are some more intricate rules for exponents. And that's what I want to go over today. So, let's ask ourselves this question. X times x. What does this give us? Well, if we remember, anything times itself, like we have up here, -2 times -2, gives us a power. It gives us an exponent. So, exponents count how many times we're multiplying something by itself. So if we have x times x, it's multiplying by itself twice. That means that we have x squared. Okay. Similarly, if we have something like x times x times x times x, well, how many times are we multiplying it by itself? 1, 2, 3, 4 times. So, we'd say this is x to the 4th. So again, what the exponent is saying is it's counting how many times we're multiplying this thing by itself. Particularly counting is the thing I want you to think about there. Because then if we have something like x to the 3rd, okay, times x to the 2nd, what we're saying here is we have 3 x's here, and we have 2 x's here, and they're all being multiplied, so how many do we have altogether? Well, we have... Oh, shoot. It did the thing. So x to the 3rd and x to the 2nd, we have 3 x's here, we have 2 x's here. How many do we have altogether that are being multiplied? We have x to the 5th. So, the rule for this one. If we multiply numbers together, then add the exponents. And this could be for anything. It doesn't even have to be x's and y's and things. It could be just regular numbers. So for instance, if I have 3 times 3 times 3, how many 3's do I have? I have 3 of them. So that'd be 3 to the third. And then we could, of course, calculate what 3 to the third is. But anytime that you are multiplying numbers together, you're going to add their exponents. So I'm going to go ahead and highlight this. That's rule number 1. Okay? So what if we have something like this? X, oops, that's still superscript. So x times x all over x. Let me make this into a fraction so it looks better. Insert, where's my equation? Oh, whatever. I'll do it a different way. X times x divided by x. Okay. So, again, what we have here is we have two x's multiplying, but then another x dividing. Well, remember that when we are working with solving equations, if we're trying to get something off of x, maybe we have like 2x, and we want to get x by itself. What we would do is we would divide by 2, because 2 times x, then divide by another 2. The 2 that's multiplying by the x and the 2 that's dividing cancel, because they're doing opposite things. So, we have x times x divided by another x. These cancel, and we're just left with a single x. X to the first. Here's another way of looking at this, though. X times x we know is x squared. So we could say that this is x squared divided by, stop doing superscript. Oh my goodness. Divided by x, or x to the second divided by x to the first, which would again come out to be x to the first. So what's happening here is where this one, when we multiply, we add the exponents together. Here, when we divide, just like the division being opposite of multiplication, we're going to be subtracting. So when we multiply, we add. The opposite is true here. When we divide, we subtract. So if I have something like x to the fifth, and I say, okay, divide by x to the second. Okay? Again, when we divide, we subtract. So 5 minus the 2 is going to give us x to the third. All right. Going to see if I can get this to auto-generate. Nope. I'll just have to do it myself. So here's our next rule. If, why is that superscript? If we divide, it is divide numbers, then subtract the exponents. So these are opposites, like I said before. If we multiply numbers together, we add their exponents. If we divide numbers, then we subtract their exponents. Okay? Now something interesting happens with this if we have something like, let's say the other way around from the example we just did. Let's have x to the second divided by x to the fifth. Okay, well, 5 minus 2 is positive 3. 2 minus 5 is negative 3. Now, we do not want to leave this as a negative exponent. It's not like the world's going to collapse or anything if you do. However, there's a more appropriate thing to do here. And that is to go ahead and do what this negative exponent is telling us to do. A negative exponent tells us to take the reciprocal. It does nothing else except for tell us to take the reciprocal. So you might have heard of that before when, dividing fractions. So if you have one fraction divided by another, what you do is you multiply, so flip that division into a multiplication by the reciprocal. So flip the other fraction, flip the second fraction. So multiply by the reciprocal means we flip that other fraction. Same thing here. This thing says take the reciprocal of this number. So we're going to take the reciprocal of x, or in other words, flip x. What does that mean? Well, if we were to flip x, right now this is really like x over 1. Flip that, it'd be 1 over x. And so now that negative's gone, but the 3 isn't gone, it's still there as a positive exponent now. Okay. Next rule. What if we have something like x to the second raised to another power? Say 3. All right. Well, we already know that x to the second is x times x, so what does it mean to add another power to that? Take it in steps. Again, we know that this is x times x, so let's separate that out. X times x, and it's still to the third power. Okay? So we have x times x here, and then we have another third power here. Remember that this tells us how many times we're multiplying this thing by itself. So we have x times x times another x times x, so there's our second one, times another x times x. There's our third one. There's our third power. So inside of the parentheses is our second power, and then all together this is our third power. So how many x's do we have all together here? Remember that when we just multiply these things together, we add up everything and see what our exponent is. So 1, 2, 3, 4, 5, 6. So this comes out to be x to the 6th power. Another way you can look at this is, well, we have two of them 3 times. Again, 2x's 3 times, 2x's 3 times. 2x's 3 times. Well, what is 2 times 3? 2 times 3 is 6. There's our next rule. So, if we raise a power to a, let's say another power, then multiply the powers. Highlight that. So there's our third rule. If we raise a power to another power, then we multiply them together. And again, the reason we say that is because, okay, we know we have this many x's in here. We have 2 of them here. But we've got it 3 times. So 2 3 times, or 2 times 3, is what we're saying there, is 6. Same as if we had, 4 there. Whoops. We had 4. 4, 3 times 4 would be 12. This would be x to the 12th. Okay? So again, if we raise a power to another power, then we multiply those powers together to get our result. Alright. And one last one. Well, if these are opposites of each other, so multiplying and dividing are opposites, does exponentation, does a power have an opposite? Yeah, the opposite of a power is a root. So let's see if I can find the root symbol. More symbols. No, can't find the root. All right. So I can say, just for the time being, SQRT is square root. Okay. So if I have the square root of x to the 6th, oh, whoops. Okay. Remember, this would be a root symbol, like a crook, with a 2 in there. So we would take the 6 and divide it by the 2. Because, again, that would be the opposite of what we're doing up here. If we raise a power to a power, we multiply. If we take a root of a power, we're going to divide. So the square root of x to the 6th, again, take the 6, divide it by the square, or the 2, part of that square root, and we get x to the 3rd. Okay. Suppose I could use Wolfram Alpha. Okay. So SQRT x to the 6th. Okay, so remember, there's an imaginary 2 in this crook of this root. So we take the 6, divide it by the 2, and we get x to the 3rd. Okay? So there's our rule. If, that's still superscript, if we take a root of a power, then divide the power by the root. And there's our last rule. So we have 4 in total. If we multiply numbers together, then just add the exponents and we get our result. If we divide numbers, then subtract the exponents. If we raise a power to another power, then we multiply those powers together to figure out what we have. And if we take a root of a power, then we divide the power by the root. Okay? Now keep in mind, we don't just have square roots. We can have third roots, and fifth roots, and fourth roots, and sixth roots, and eighth roots. All sorts of different types of roots. But whatever denomination that root is, so for instance, if this was a third root, then we would be doing 6 divided by 3 for third root, and we'd get 2 over here, x to the second, because 6 divided by 3 is 2. Okay. So, I believe that will do it for today. So next time, I think I might just give us a little bit of time to work on whatever we need to work on in Hawks. But I do know that we will be getting some practice with these on Wednesday. So I will be recording another one of these on Wednesday for us to see. And I'll be doing some practice with these rules. But again, for today, that's just going to do it. I hope you all have a great day, and I'll see you on Wednesday.